am Dr. Ramanuja, Associate Professor, Department of Mathematics, Laxman Reddy Institute of Technology, Dundigal, Hyderabad. Today I am extending 3.2 module about Lagrange's mean value theorem. Already previous lecture we studied about continuous functions and also Rolle's theorem and its geometrical interpretation. In 3.2 I am going to discuss about Lagrange's mean value theorem statement as well as its geometrical interpretation and with example problems. Okay, let us go with the 3.2 module. I am going to discuss about the Lagrange's mean value theorem as well as the geometrical interpretation. The statement of the Lagrange's mean value theorem. Previously, what we studied, f dash of c value is always 0 in between a and b in the Rolle's theorem. Whenever we draw the tangent to the chord is always parallel to the x-axis. See here the statement about the Lagrange's mean value theorem, f is a continuous in the closed interval a, b to r, a real number system we are studying always. And also the statement says that f is always continuous in the closed interval. F is a continuous in the closed interval a, b. Then the f must be differentiable in the open interval a, b. Whenever we define differentiability is always in the open interval a, b. There exists a point c between the open interval a, b, f dash of c equal to f of b minus f of a by b minus a. This is the statement about the Lagrange's mean value theorem. What is statement? He says f is a continuous in the f is a defined in the function defined from a, b to r, and also f is a continuous in the closed interval a, b. F is a differentiable in the open interval a, b. Whenever there exists a point c between a and b, f dash of c value is equal to how much? F dash of c value is equal to f dash of c equal to f of b minus f of a divided by b minus a, which is the statement of the statement about the Lagrange's mean value theorem. Let us go with their geometrical interpretation of the Lagrange's mean value theorem. See, in Rolle's theorem, what we observe, their f of a value is equal to f of b. Now here f of a value, f of b value are not always equal. So already we studied about some functions, whenever we substitute, both values are not equal. Such a cases we are going to apply the Lagrange's mean value theorem. When they are both are equal, we can apply the Rolle's theorem. Let us go with the what his geometrical interpretation. He says f is a continuous function satisfy the Lagrange's mean value theorem in their graphical representation. Whatever we define, we taken some x equal to a is a at this particular point. At the particular point x equal to a, at this particular point what it represent? F of a. We define one point b here. When we draw a line here, it becomes f of b. Now this function is a continuous in between a and b. When we draw a tangent, when we draw a tangent at the particular point of c, f dash of c value. What is f dash of c value? F dash of c value is nothing but how much? F of b minus f of a divided by b minus. Already familiarized by the slopes. When we join these 2 points, which is nothing but this is f of a, this is f of b. Okay. See, what is the slope? He says the difference between the y coordinate divided by the difference of the x coordinate. Therefore, f dash of c is equal to what? F dash of c equal to what? F of b minus f of a divided by what? B minus a. This is called, this is the statement about the Lagrange's mean value theorem. This condition must be satisfied. What happened? Now f of a, f of b values are not equal. See, at this particular point, when we draw a tangent, this tangent is also a parallel to the chord. This tangent is parallel to the chord. This is one kind of the geometrical representation. See, the function is not always a constant between a and b. There is so many points in between a and b. Let us look this point x equal to a, and I can say this one is a f of b a. At this particular point, I can define some point b. At this point f of b, I can define some other points here. Like this, we can define some values of c. At this particular point, I can define some points of d. I can define some points of e. Like this, if I define every point between, because here f of a value, f of b values are not equal. Therefore, when we join these lines, along the x coordinate, along the y coordinate, this is nothing but what? F of a value. This is nothing but what? F of b value. How do you get f dash of c value? F dash of c, this at this particular point when we draw the tangent at this particular point, tangent c, f dash of c value equal to what? F dash of c is equal to f of b minus f of a divided by b minus a. At this point of the tangent, this tangent, when we draw the chord between these two chords are parallel. Similarly, whenever we take these points are parallel to this chord, therefore we can say there is a unique tangents can be drawn to the parallel to the chords. Okay, this is about the statement about geometrical representation of the Lagrange's mean value theorem. Let us go with one example problem we can apply for the Lagrange's mean value theorem for this function. Okay, let us go with the verify the Lagrange's mean value theorem for the function f of x equal to log e base x in the interval closed interval 1 comma e. Okay, already we know what is the given function here. Let f of x is equal to, what is the defined function? Log x to the base e. For this function, f of x is, let f of x is continuous. What is statement? He says continuous in closed interval 1 comma e. F is a continuous in closed interval 1 comma e, and also f of x is differentiable. F of x is differentiable in open interval 1 comma e. F of x is differentiable in open interval 1 comma e. What he says, we need to calculate f of a value, we need to calculate f of b value. Okay, what is a value now? A equal to 1 and b equal to e. F of x is equal to what? Log x. Okay, I can substitute. A value is 1. What happens? F of 1 is equal to log 1 to the base e. What is log 1 value? Is 0. Similarly, we need to substitute b value. What is b value? B value is e. F of e equal to log base e into e. What is log base e into e? Is 1. There exist, whenever we see f of a value, f of b values, are they equal? No. In the Rolle's theorem, what happens? F of a value is equal to f of b. Therefore, we are extending the derivative. There exists a point c between open interval 1 comma e. There exists a point c between what? We need to calculate the c value between what? 1 comma e. Okay, let us go with their derivative. What is the f of x? What is f of x is given? F of x equal to log x. What is the derivative of f dash of x? F dash of x equal to log x, derivative is 1 by x. What is the next condition? Lagrange's mean value theorem says f dash of c equal to f of b minus f of a divided by b minus a. See, what is f dash of c value? What is f dash of x value we got? F dash of x value equal to 1 by x. It becomes what? F dash of c equal to 1 by c. 1 by c is equal to, what is f of b value? What is f of b value is how much? F of b value is 1. 1 minus 0 divided by b. What is b value? B value is e. What is a value is 1. If I simplify, 1 by c equal to 1 by e minus 1. If I cross multiply, c equal to e minus 1. C equal to what? E minus 1. C equal to e minus 1. Already c value we got in between the intervals of what? In between the intervals of 1 comma e. 1 comma e. See, already you know what a value is 1. Already you know what is e value, 2.732 something. There is approximate value. What c value we got? C equal to what? E minus 1. What is e value? I told 2.732. If you subtract minus 1, c value lies in between 1 comma e. Therefore, c equal to what? E minus 1. Therefore, log f of x equal to log x satisfies the Lagrange's mean value theorem, where the c value lies between 1 comma e, with that is c value, c equal to how much? E minus 1. This is the example of the example problem number 1. Let us go with one more problem. Second problem, verify the Lagrange's mean value theorem for the function f of x equal to x cube minus x square minus 5x plus 3 in the closed interval 0 comma 4. This is a polynomial function. Already you familiarized by polynomial function. Polynomial functions always say continuous functions, okay, and also differentiability. Okay, let us take the function. What is the function is given? F of x equal to x cube minus x square minus 5x plus 3. This is the function. This function, what are the value in between? Where? In between of 0 comma 4, closed interval. What is a value? A value is 0. What is b value? B value is 4. Already we know the statement about the Lagrange's mean value theorem. F of x is continuous in closed interval 0 comma 4. F is a continuous in the closed interval 0 comma 4. Similarly, f of x is differentiable in open interval 0 comma 4. F of x is differentiable in open interval 0 comma 4. We need to calculate f of a value, we need to calculate f of b value. Okay, what is a value? A value is 0. What is b value is 4. Okay, f of x, what is f of x value? X cube minus x square minus 5x plus 3. We need to substitute what? X equal to 0. X equal to 0 means what happens? If we substitute this one, 0 cube minus 0 square, 5 into 0 plus 3. What is the remaining value? This becomes f of 0 value. F of 0 value becomes 3. Similarly, we need to substitute 4 value, 4 in this equation, polynomial 4 cube minus 4x square minus 5 into 4 plus 3. What happens? What is meant by 4 cube? 64 minus 4 square, 16 minus 20 plus 3. Totally this becomes 67 minus 36. This is nothing but 31. F of 4 value we got. What is f of 4 value? 31. But Lagrange's, he told, always there exists a point, point C between open interval 0 comma 4. We need to verify open interval 0 comma 4. See, there exists a point 0 comma 4. What is the condition? F dash of C value is equal to f of b minus f of a divided by b minus a. Still we need to calculate what? F dash of C value. Derivative we are going to calculate. What is f dash of x value? What is x cube derivative? 3x square. What is the derivative of x square? 2x. What is the derivative of 5x? Minus 5. What is derivative of constant? 0. This is the derivative of f dash of x. Now I am going to substitute f dash of c. This becomes 3c square minus 2c minus 5, which is equal to, what is f of b value? How much we got f of b value? 31 minus f of a value, how much we got? 3 divided by, what is b value? B value is how much? 4. What is a value? 0. Therefore, 3c square minus 2c minus 5 equal to, if you subtract this one, 28 divided by 4. If we cancel, this becomes 7. Therefore, 3c square minus 2c minus 5 equal to 7. Therefore, 3c square minus 2c minus 5 minus 7 equal to 0. Therefore, 3c square minus 2c minus 12 equal to 0. We need to calculate the root, the value of c, that c value lies between 0 comma 4. Okay, let us go with the one more slide. 3c square minus 2c minus 12 equal to 0. Minus 12 equal to 0. This is a quadratic equation. We know how to solve the quadratic equation. What is a value? A value is 3. What is b value? Minus 2. C value is minus 12. Therefore, c equal to minus b plus or minus under root of b square minus 4ac divided by 2a. Okay, C equal to, what is B value? B value is minus 2. If you substitute here plus 2, plus or minus, or you can use calculator, you can calculate the roots of the polynomial equation. Let us go with B square. What is B square? Minus 2 whole square minus 4 into A value is 3. What is C value? Minus 12 divided by 2 times 3. Therefore, C equal to 2 plus or minus under root of minus 2 whole square. This becomes plus 4. This minus of minus plus. This 4 times 3, 12. 12 times 2, 144 divided by 6. C equal to 2 plus or minus under root of 148 divided by 6. We got the value of C. Now we need, how do you write this one? How do you write this one? 4 times, how do you write this one? C value now? C equal to 2 plus or minus under root of 4 times of 37, I can write, because divided by 6. If I take 2 common, it becomes 1 plus or minus under root 37 divided by 3. Therefore, C value becomes 1 plus under root of 37 by 3, one positive value we got, and similarly C value lies between 1 minus under root of 37 divided by 3. See, where this lies between, what we say, we need to calculate where to where? In between 0 and 4, because wherever there exists a point, this the condition is very important, f dash of C value always lies between 0 and 4. We got 2 values, or you can solve this value by using calculator also. I am not going to consider this value, I am going to consider C equal to 1 plus under root of 37 by 3. See, there is a open interval 0, 4. This is a 0, 4. There exists a point C in between. C equal to how much? 1 plus or minus root 37 by 3. You can calculate, you know, already 36 square root of 36 is 6. We can calculate the value of C. The C value always lies between 0 and 4. Therefore, this function is a continuous as well as differentiable, and also always exists between A and B. F dash C value becomes what? 0. This is about the problem number 2. Let us go with one more problem. This is also very important problem. We are going to apply some trigonometric functions. Already we discussed about one problem by logarithmic, second problem we discussed by polynomial. Now we are extending into the trigonometric functions. Okay, using Lagrange's mean value theorem, we are going to prove some inequalities. B minus A by 1 plus B square less than tan inverse of B minus tan inverse A less than B minus A by 1 plus A square. This is one condition. We are going to apply what? Lagrange's mean value theorem. Using this condition, inequality condition, we are going to prove tan inverse of 4 by 3 value in between, and also tan inverse of 2 also in between of tan inverse of 2 in between of pi by 5 plus 4 by 20 less than pi plus 2 by 4. This is the second condition about the Lagrange's mean value theorem. Okay, look this function. How do you select this function in this case now? Okay, tan inverse of B minus tan inverse A. We are defining some function which is called as a trigonometric functions. Already you know trigonometric functions, tan inverse function is a continuous in between the interval values. Okay, let us define the function. Let f of x is equal to what I am considering? Tan inverse x. Okay, for this tan inverse x, I am going to define in the interval values of A and B, because we are not going to consider the particular values between previous problem. There is a polynomial function, particular value we define. Now we are not going to define particular, we are fixing the points of A and B. Okay, f of x equal to tan inverse of x. Okay, f of x is, what is the condition? First condition says f of x is continuous in closed interval a comma b. F of x is continuous in the closed interval a comma b, and f of x is differentiable in open interval a comma b. F of x is differentiable open interval a comma b. What is third conditions? He says we need to calculate what? F of a value, we need to calculate f of b value. What is f of x? F of x equal to what? Tan inverse of x. We need to calculate f of a value. What happens? Tan inverse of a. Similarly, we need to calculate f of b value. What happens? Tan inverse of b. Okay. Whenever we calculated their f of a value, f of b value, both are not equal. Already we discussed equality means what kind of the theorem we are going to apply. And also we need to calculate f dash of x value. What is f dash of x value? We know the derivative of tan inverse of x. What is tan inverse of x? 1 by 1 plus x square. And also Lagrange's, he told about their condition. What condition he told? F dash of c is equal to f of b minus f of a divided by b minus a. This is the condition about the Lagrange's. Already we know f dash of x. We need to calculate what? F dash of c. What is f dash of c? 1 by 1 plus c square. What is f of b? Already we know f of b. What is f of b? Tan inverse of b minus f of a. What is f of a? Tan inverse of a whole divided by b minus a. Okay, what we calculated? F dash of c value. How much it becomes? Tan inverse of b minus tan inverse of a divided by b minus a. See, there exists always a point in the open interval a comma b. There exists a point C in between A and B. Let us write, how do you write existence of C value in between A and B? Okay, this is the inequality I express. C always lies between what? A and B. Let us make their square values. What happens? A square is also what? C square less than B square. Suppose I can add plus 1. Is there any change in their inequality? There is no change. 1 plus c square less than 1 plus b square. If I make the reciprocal of these values, if I make the reciprocal 1 by 1 plus a square greater than 1 by 1 plus c square greater than 1 by 1 plus b square. How do you write this condition? How do you write this condition now? 1 by 1 plus a square greater than, what is 1 by 1 plus c square value? What is 1 by 1 plus c square value? Tan inverse of b minus tan inverse of a whole divided by b minus a greater than 1 by 1 plus b square. Okay, if like this, I can interchange the inequalities of b minus a. This becomes what? B minus a divided by 1 plus a square greater than tan inverse of b minus tan inverse of a greater than b minus a divided by 1 plus b square. Okay. Now I am going to rewrite this inequality. I am going to write this inequality in the proper order. If I write, how do you write this one? B minus a whole divided by 1 plus b square less than tan inverse of b minus tan inverse of a less than b minus a divided by 1 plus a square. Now we got the inequality of this result. What do you got now? We used Lagrange's mean value theorem. We applied the Lagrange's mean value theorem. We derived the tan inverse function inequality. How do you get tan inverse b minus tan inverse a in between of these two values? Okay. For this inequality, we are extending by substitution of, by using this inequality, we are deducing the two inequality condition. One is tan inverse of 4 by 3 and one is tan inverse of 2. And this is tan inverse of 2 and tan inverse of 4 by 3. Okay, already we derived the inequality. That inequality nothing but what? B minus a by 1 plus b square into tan inverse b minus tan inverse a by b minus a. We will use this result. We will use this result. We are going to prove this inequality now. Okay, clear I think. Now what condition we applied? What result we got previously? B minus a b minus a divided by 1 plus b square less than tan inverse of b minus tan inverse of a less than b minus a by 1 plus a square. See, in this case, we need to calculate what value we are going to observe first. What value we need to calculate? 4 by 3. This is the end of the interval values. Okay, which interval we are going to start? Okay, in the question itself, it shows what value we are going to start. Okay, what is the ending value we are going to fix now? B value I am going to fix 4 by 3. Let us assume a equal to 1. We are substituting a equal to 1 in this inequality. What happens? 1 minus 4 by 3 whole divided by 1 plus 16 by 9 less than tan inverse of 4 by 3 minus tan inverse of 1 less than b minus a. This one is b minus a. b minus a means 4 by 3 minus 1. Here also 4 by 3 minus 1 whole divided by 1 plus 1 square. Okay, if I take this LCM, what happens? This becomes 1 by 3 numerator whole divided by, this becomes 25 by 9. 25 by 9 less than tan inverse of 4 by 3 minus, already you know what is this one. How do you write tan inverse of 1? Tan inverse of 1 means what? 1 can be written as tan pi by 4. Tan inverse of tan, which is nothing but pi by 4, less than, this becomes 1 by 3 whole divided by 2. Let me simplify this result. What happens? 1 by 3 into 9 by 25 less than tan inverse of 4 by 3 minus pi by 4 less than 1 by 6. This will be gets cancelled. This becomes what? 3 by 25 less than tan inverse of 4 by 3 minus pi by 4 less than 1 by 6. Now, we need to calculate what? We need to calculate tan inverse of 4 by 3. Suppose if you, how do you calculate tan inverse of pi by 3? This entire inequality, we are going to add plus pi by 4. Then this negative pi by 4 becomes 0. Therefore, 3 by 25 plus pi by 4 less than tan inverse of 4 by 3 less than 1 by 6 plus pi by 4. Now, we got the inequality of what? Pi by 4 plus 3 by 25 less than tan inverse of 4 by 3 less than pi by 4 plus pi by 6. If you want to calculate any tan inverse of this value, you can use this inequality. We can find the value. That value is always in between of these two. Okay. Let us go with one more inequality. This is the second inequality. We will use same inequality proof. We are substituting different values. Okay, what is already inequality here? B minus a divided by 1 plus b square less than tan inverse of b minus tan inverse of a less than b minus a whole divided by 1 plus a square. This is the previous inequality we are using. We will use this inequality. We are going to deduce the value of tan inverse of 2. Okay. Already end value we fixed. What is the end value we fixed? B value already we fixed what? 2. Now we are going to take the initial values. Let us assume a equal to 1 now. What happens if we substitute this inequality? 2 minus 1 by 1 plus b square. B square means 2 square less than tan inverse of 2 minus tan inverse of 1 less than 2 minus 1 divided by 1 plus 1 square. What happens? This becomes 1 by 5 less than tan inverse of 2 minus tan inverse 1. 1 already I told, 1 can be written as tan pi by 4. Tan inverse of tan pi by 4, which is nothing but pi by 4 less than 1 by 2. Now, how can you write 1 by 5? 1 by 5 plus, I am going to add pi by 4 this inequality plus pi by 4 less than tan inverse of 2 less than 1 by 2 plus pi by 4. If I take this LCM here 20, this becomes 20 divided by 5 4 plus 5 pi less than tan inverse of 2 less than, what is LCM here is 4. What is the resultant value? This becomes 2 plus pi. How do you write the inequality? Now look this inequality. How do you write this one? 5 pi plus 4 divided by 20 less than tan inverse of 2 less than pi plus 2 whole divided by 4. This is the inequality we proved. Okay. Once I am going to repeat the statement about the Lagrange's mean value theorem, and we can observe all the conditions. Okay, what is the statement? He says f is a defined from a b to real number system R, and also f is a continuous in the closed interval a b. F is differentiable in open interval a b. Always when there exists a one point c between what a and b. We need to calculate what f dash of c value derivative. We need to calculate f dash of c equal to f of b minus f of a divided by b minus a. This is about Lagrange's mean value theorem in the 3.2 module.